So welcome to another class in programming 8085. So today's program is going to be exchange a block of n bytes. Okay. So in the previous program we saw how do you transfer a block of n bytes. So you transfer from one location to the other location. In the previous program we transferred from 1100. We transferred 10 numbers to another location which was 1200. So 10 locations we have transferred them. We also saw another program for reverse transfer. We transferred the same 10 numbers, but we transferred it in the reverse order. So that was transfer of a block of n numbers in reverse order. So today we are going to discuss about exchange a block of n numbers, meaning we will exchange the numbers. Say for example, I have a block of n numbers from location 1100 and another block of n numbers in location 1200. That block will be the block which is stored from 1200 will be transferred to 1100. 1100 should be transferred to 1200. Okay, so it's like there will be two numbers A and B. So you will transfer value of A has to go to B and B has to go to A. So in that case you will use a variable called swap variable in between. A temporary variable will be used. So in that case you will store A's value in the temporary variable, then B value will be stored in A, and from the temporary variable that value will be stored in B variable. Similarly we will do it with a block of memory locations. Same concept, same logic, but we are going to do it with a block of 10 values. So we are going to exchange the block. Right, so let us begin the program. The first line says MVIC comma 10. Here we are going to give the n values. So n here is nothing but 10. In our case you can make it 5, you can make it 2, 3, it's up to you. In this program we are going to transfer a block of 10 numbers. So block of 10 bytes we are going to transfer. Okay, yes. Second, LXI H comma 1100. We have seen this in many examples. So now I can tell you directly that HL register will be pointing to 1100 is the meaning of it. LXI D comma 1200, the meaning of which is D register pair will be pointing to 1200. So we will be having two register pairs which will be pointing to these memory locations. HL register pair pointing to 1100 and D register pair will be pointing to 1200. Right. So now what I should do, I should take one number and then transfer it to the other memory location. That's what we are going to do. So let us see how we are going to begin the process. So this is how I have stored my numbers. I have stored my numbers 1100 to 1109. I have stored numbers 11 to 20. Similarly 1200 I have stored 21 to 30. So now what I should be doing, I have to transfer 21 to 30 has to move to location 1100 to 1109 and 11 to 20 has to move to locations 1200 to 1209. So that is the task given to me. How am I going to code it? Is what we are going to see now. Yeah, let us begin the process. So now, as of now, my input will be at 1100, 10 numbers starting from 1100 and 10 numbers starting from 1200. I have my inputs ready. Now let us move on. How am I going to proceed with the exchange process? Okay, LDAX D. So what does that mean is load from the D register pair value has to be loaded to the accumulator. The D register pair in this R case is actually storing or pointing to 1200. Okay, so the value 21 has to now move to A. Load value from the D register pair. So D register pair will be actually having a memory stored into D register pair. The value stored in that particular memory will has to be loaded into your accumulator is the meaning of LDAX. So my 21 is going to be loaded to my accumulator. Now my accumulator contains 20. Next step, line number 6, move B comma A. So A value has to be moved to B. Now B becomes 21. Here B acts as that temporary register used for swapping. Okay, so this is going to be register B. So what I did, I took one value stored at 1200 and I have now stored that value in B. Okay, now I can overwrite 1200 is the meaning of it. Okay, yes. So let's see line number 7, move A comma M. So what is M? So whatever is the memory pointed by HL register pair, that value will be your M. So HL register pair is pointing to 1100. So my M value is 11. Okay, now my M value is 11. I am moving that M value to register A. So now my A now becomes 11. So let me overwrite it. My A is going to become 11. Right, so that is what happens. So when I say move A comma M, my M value which is 11 is going to be moved to A. Okay, now I am going to say STAXD. So A has to be stored in the D register pair memory location. So A has to be stored in the memory location which is pointed by D register pair. D register pair in our case is now pointing at 1200. So whatever value is there in A, I am moving it into 1200. Yes, line number 9, move M comma B. So B value has to be moved to M. B has 21. So what is M? My M now is 1100's value, right? So 21 goes here. So what we have done, so far what we have done, we have only taken this particular row. Only we have taken 1100 and 1200 and we have swapped the elements. 1100 had 11, 1200 had 21. Now we have successfully swapped it. The same process will continue for all the 10 numbers. So what we should do? We should increment HL register pair, we should increment the D register pair, and we have to decrement C because we have to do this whole process only for 10 times. Okay, so C we have initialized to 10 in the beginning. We will keep decrementing it. When it went to 0, by then you would have finished all the exchange process and you can come out of the loop. Okay, so let us see the other things what we are doing here. So we are going to, as I told you, we will be incrementing HL register pair, we will be incrementing the D register pair, and we will be decrementing C. Okay, when C is 0, we will come out of the loop. Otherwise, we will have to go to line number 5 where you have continue. Right, clear? Hope you have understood this exchange block of n numbers. Please do execute it either using Ultimate 8085 in your mobile or using GNU simulator in your laptops. Thank you.